Boom! So we're continuing in our series on binary operations. As you can see here, we have 4 different operations. We will establish the binariness of these soon. And we have, for each of these 4 operations, we have 4 unique operators. So in other words, the operator, each operator signifies one and only one unique operation. You can't use the same operator to signify 2 operations. It's a one-to-one relationship. One operator, one operation. The operands could change. The operands could be the same. You can use the same operands across 4 different operators, across 4 different operations, just as we did in the previous video. Alright? But one-to-one where operations and operators are concerned. So we have A star B. You have A here and you have B here. 2 operands, binary operation. You have P, funny symbol, Q. That is equal to Q squared minus P squared. Right? So you're squaring the Q, you're squaring the P, and then you're subtracting. That's a whole set of operations mixed up there. Same story here. You're adding and then you're dividing. Combinations. Right? You have M triangle N. M triangle N is 1 over M plus 1 over N. Right? You reciprocate the M. In other words, you have 1 over M. You reciprocate the N, you have 1 over N. 1 over M plus 1 over N. Boom. Combination. Same story here now. V, circle with the cross inside. W is equal to the square root of W minus the square root of V. This here is the operation. The V and the W are the operands. This symbol here is the operator. Alright? So we have the binary operations defined generically. We define it in a way that will allow us then to input any pair of values for the operands, the variables, so to speak. So for example, if we want to say 8 star 12. So in other words, 8 star 12, and I want to make this point very forcefully, that the order in which the values are written must subscribe to the order in which the variables are written, right? A and B variables, because the values could vary. We don't know what the values are. 8 and 12 values, because we now have specific values for these 2 variables. So if we have A star B and you have 8 star 12, then the A must correspond to the 8 must correspond to the A, and the 12 must correspond to the B. Always, always, always. Do not mess with that at all. Must correspond. Alright? So if A star B is equal to A plus B over 2, then A star 12 naturally would be 8. 8 for A plus 12. 12 for B over 2. 8 plus 12 is 20. 20 divided by 2 is 10. We work that out. No problem. Right? Let me just make a note of that, because I think I would need it a little later. Yeah, hold on. Alright, 8 star 12 is 10. Alright. Yeah, we're going again. So the second operation, we have 3 circle with the cross 17. Let me use a different color ink now. You have 3 circle with the X, circle with the X 17. Again, the 3 corresponds to the P, and the 17 corresponds to, not 17, 7. And the 7 corresponds to the Q. So that will be what? 7 to Q. You have Q here. So that will be 7 squared. P, 3 to P. So I have P squared here. 7 squared minus 3 squared. 7 squared is 49 divided by, 49 minus 9, which is equal to 40. Alright? So So we work out that, and we take a note of that as well, because we're going to need it a little later. Hold on. Don't go anywhere. Right? Remember what I would suggest you do as I am working it out and talking. Try and write as well. Follow what I'm doing. That's part of your learning process. Right? So then we have with the triangle now. We switch into, we have some space here, man. Now, we need some more space, so let it above. Because this one is a different one. We need a few more lines for this one. Alright? So, we have now M triangle N, and we are required to find 5 triangle 9, which will be the same as 1 over M, M for the 5, 1 over 5, plus N for 9, plus 1 over 9, which is, I just work it out here just so that you can see it, right? 1 over 5 is the same thing as 9 over 45. 1 over 9 is the same thing as 5 over 45. Right? Right? 9 plus 5 over 45 is 9 plus 5 over 45, which is equal to 14 over 45, right? There's a separate video that I did on the additional fractions, so I don't have to explain everything that I did here. What you could do is check that out if you're interested, so that you start to put the little pieces together that need to be put together. All right, so 5 star 9, let me see, I want 9 if I needed this one. 5 star 9 would be 14 over 45. All right, and then we have 36, circle with the cross, 64. So now I think we have enough space for that. 36 circle with the cross, 64 would be what? Let me switch it up the black. 36 circle with the cross, 64 would be W for 64, right? Because the 64 comes after the operation, after the operator, right? Which would be, so this will be therefore be root 64 minus V for 36, V for 36, 36 for V. So root of 64 minus the root of 36, minus the root of 36, which will be 8 minus 6, which will be equal to 2. Yeah? So some nice simple examples to demonstrate the point. What I hope that you have seen from these 4 examples, I'm going to write here so I could give you my full attention. What I hope that you would have seen from these 4 examples is that binary operations, when you drill it right down to the basics as a matter of execution, is nothing more than substitution. That is all it is. That is all it is. Alright? Because look at how I could rephrase these same operations and switch it over into algebra now. I could say, for example, that I could say, now I want you to watch carefully here. I could say, for example, that I could say, if y is equal to a plus b over 2, right? Find y when a is equal to, let me use the same values we had here. A is equal to 8 and b is equal to 12. I could say that, right? I could say that, and even though the problem is couched differently, it is expressed differently, right? Because depending on the topic that you're dealing with, the expression will be a little different. At its very core, the solution to this is exactly what you just did when we treated it as a binary operation. All right? It is not necessarily a binary operation. Here, we wouldn't look at this and say binary operation because we have a variable here, a variable here, and a variable here. All right? But it's the same substitution. So what I want you to understand is that you could extend your substitution into binary operations in the sense that once you understand the basics, once you understand the fundamentals of operator, operation, operand, the fundamental of the fact that you need two operands before you could refer to an operation as being binary, or before you could refer to an operator as being binary. Once you understand that, everything else is just substitution. So treat binary operations as an extension of your substitution at the very beginning of your algebra. All right, let me go again. Another example. I could say, for the sake of argument, I could say, and I'm doing this deliberately now, I can say f of m comma n is equal to 1 over m plus 1 over n, which is not something you would see in a question at the level of Form 5. 15, 16, 17 year old, right? You'll see this more at the level of Form 6, but I'm just making the point. This is what we refer to as a function of two variables. So instead of saying f of x or f of y, or instead of saying f of m or f of n, we could say f of m comma n is equal to m, 1 over m plus 1 over n. I could then say find f when, let me see the same variable values we have, when m equal 3 and n is equal to 7. Yeah, it's the same thing. It's the same thing. So once you get the hang of your substitution down, once you get the hang of your binary operators down, what you are in fact doing is setting the table. You're building your foundation to be able to execute much more complicated functions. As you see here, you get a little preview here. Instead of having a function of one variable, you can have a function of two variables or three variables. The same basics that you do when you're dealing with one variable, you just extend it for 2 and 3. Of course, the algebra and the arithmetic will be a little more complicated simply because you have more variables, but that's a little further down. So this is more or less the end of the second video on binary operations. All right, we're taking our time with this. This is a topic that a lot of people get problems with, so we're taking our time with it. If you hear any video, I hope it's because you watch the whole of the first video and you watch the whole of this video as well. All right, so we have one more video in this series, so stay tuned.